One of the areas for improvement in computer graphics is to move from where we're working with dumb geometry, where you have to push and move point by point, curve by curve, object by object in order to do an animation, to where behaviors and physical properties are built into the objects that make up the animation. Now, one of the areas where we've done some work on this, in this case YOS-STEM, is where we're doing fluid dynamics, where here we have virtual smoke that's computer generated, interacting with a live person caught on a video camera. In this case, we tracked the closest point to the lens, namely the tip of the finger, and used that to stir up the virtual smoke. And here you can see from the side view what's going on and how this is working. Now, this is fine for a start, and it's something we did about a year ago. What I want to show you now is what happens when we go one step further and allow you to interact with geometry as well as the finger. So here's a 2D simulation of the same thing. My finger, like in the previous example, is stirring up the fluids and moving them around. But what's interesting now is, besides interacting with my finger, I can start to paint in geometry. So little pieces of barriers that affect the flow of the fluids. And what I want you to notice is how the fluids are behaving properly. That is, we're starting to get a much more accurate simulation, a more complex simulation. And as I stir the fluids, again, watch how they all flow around through this environment. Now, what you have to imagine here is that everything we're showing here in 2D works likewise in 3D. And so you can imagine a situation in a video game where a character is running down a corridor full of other types of geometry, runs into a cloud of smoke or cloud, and the smoke disperses, bumped by the body, just as like here my finger, and hits the walls and eddies and curls appropriately. And that happens automatically as opposed to being animated manually. Now, it also means that we can use this same type of simulation for other purposes. So in industrial design, for example, we can actually, as in this case, build a virtual wind tunnel. Now here we see the smoke coming through and interacting around this particular piece of geometry, a very complex sphere or oval. Now the point I'm trying to make here is that not that this is something new. We've always been able to do virtual wind tunnels. What's happening now is the ability to bring this much, much earlier into the design process and on the desktop, where using the approximations to fluid dynamics that YOS has been developing, where we can actually start to gain insights and inform the design based on aerodynamics right from the very beginning. This is new, it helps design, it helps entertainment, and it's indicative of the types of things we're doing in the future to make systems better.